Okay, hello Instagram, and then hello everybody else, and welcome to Ladyada.
Hello everybody, welcome to a Friday night Ladyada. We're streaming on multiple platforms here. If you're on Instagram, you're not going to see the overhead and stuff. You can pop over to YouTube to check that out.
Or anywhere, yeah.
But we have a fun little stream for you tonight. We're going to do a little bit of a teardown and a electronic design analysis of a Pulse Oximeter. These are pretty useful devices in general, but now they're extra useful these days because they tell you how much oxygen is in your blood. And if you have a very bad case of COVID, your lungs can't absorb oxygen. And so your blood oxygen starts dropping and dropping. And sometimes people don't even notice it. They're like the happy hypoxic, I guess, or maybe I'm not saying it right. But they don't even realize that their blood oxygen has dropped below 90%. And it can really damage your lungs and your brain and your heart. So having one of these, especially if you've gone to the hospital and they've sent you home and they said, hey, you should recover at home, oftentimes they'll give you a pulse oximeter or ask you to buy one so you can monitor your blood oxygen. We were actually doing some projects with this pulse oximeter. We were planning on doing some projects anyways a few months ago. It's just coincidentally, like bad coincidence, that now these are in the news a lot. But we got these because we were doing some Bluetooth projects. So next week we're actually going to have a John Park workshop with a Pulse Oximeter data logging project using a Bluetooth version of this Pulse Oximeter. If you want to pick one of these up, we're going to have them in the shop in the next couple weeks. You can sign up at adafruit.com. It's product 4580, and we also have a version with Bluetooth. But the ones that without Bluetooth were easier to get. They were faster to ship. So we got some of these, and when I got them, I've gotten samples of this pulse oximeter. I knew it was a pretty good one, but I also wanted to take one apart and just see how it was put together. I've never had more than one, so I never had an extra one to disassemble. So let's start by first showing how they work. So maybe we want to go to the overhead and. Okay, so we actually have two. This is the one that Phil has. I'm going to move this out a little bit for now, and I'll
Yeah, if you move your head, you can have it so you're not as chopped off, or I can get rid of your head.
You can get rid of my head. My head is not
you just want to have it as,
I can, because I can't really see. Bye.
Cool.
Okay. So this is Phil's, and this is a very nice one. That says Massimo, but this is not the same Arduino Massimo. It's just a weird coincidence.
I like to think it is.
But I like to think it is. He's on the side. He's also doing, medical device manufacturing.
He fills my blood with oxygen.
But they actually make like ventilators and stuff. They're quite a serious device company, and they have Bluetooth. But we got this for a few years ago for some, body hacking, biohacking stuff that we were doing. You put your finger in, and then you can see. It takes like 30 seconds or so, and it starts to say, okay, there's your pulse.
Okay, you're doing pretty good.
I'm doing pretty good. So you see your pulse, and then, after it gets good enough data, it says, okay, your blood oxygen is, which is called SpO2, is 100. So you want it to be like 97 or higher. If it's less than 95, you might want to talk to your doctor. And then this is your pulse rate and battery. And I think, you can twist it, and I think it can change orientation. It's a nice color display. Oh, actually, sorry, you can touch the screen, I guess. And yeah, it rotates around. Okay, that's a little bit more visible, and I'll also show the Instagram people. So this is a very nice one, and this one's very expensive and hard to get. These are simpler. They're less expensive. But it's also, you'll see, it's not as fancy. So for both kinds, you put some AAA batteries in the bottom. And then you put your finger inside. This one doesn't have a nice squishy inside. And maybe you press the button. And then if you press it again, it'll rotate. Maybe there you go. And this one also beeps a little bit. and you'll see, you just have to sit very still. And it says my SpO2 is 99. You can hear the pulse rate. I think if I press this again, it'll stop making the beeping sound. I gotta read the manual. I gotta admit I haven't read the manual. Okay, so stop beeping. So you can see it's got my pulse rate. It's got a similar little curve here, battery. And we are getting a version also that has Bluetooth. This one doesn't have Bluetooth signals, so you just have to look at it. And then when you're done, you can look inside. You can see the red and infrared LED and the sensor. And it'll automatically turn off if it doesn't see any signal. So it works, the same. Actually, what's funny is, we put both of these on one of each of our fingers and compared. And it's really close. It basically is the same. So how do these work? Well, there's actually in the manual, which is kind of a nice manual, there's a cute diagram. So I'll show the diagram if I can find it. Here you go. So now I'll zoom in again because we're going to get to the teardown in a minute. So you can, read all this text. So basically it's looking at red LED light and infrared LED light passing through the fingertip, and it detects on the other side. So there's LEDs on the top, photo detector on the bottom. It reads the red and infrared LEDs, and you can see, we've actually done projects even with like a Clue or Circuit Playground. If you just shine red or green light, or even white light, into your finger, and then read a simple light sensor off of a location near your finger, you'll see, your pulse. Like, even if you put a bright light behind your finger, you'll see the color of your finger get reddish and lightish with your pulse because of the blood pumping in, which is really neat. Like, it's very easy to measure pulse. And then pulse oximetry, I guess, is the ratio. I've never actually done a pulse oximetry calculator before. I think you need to calibrate them. So I haven't done that before. Oh, yeah.
Someone's saying that below 90 is to watch out for. 90 to 100 is still in the normal range.
Okay.
But, we're not healthcare professionals.
Yeah.
It might be unique to the individual. So I would say definitely look at what is a normal range for you personally, and also look at the ranges that are published that go along with this.
Yeah.
I think the lowest you and I have ever been was 98 or 99.
Yeah, your body is quite good if you're in fairly good health. It's quite good at keeping that blood oxygenation quite high. But yes, I'm not a medical professional. I can't advise you on exactly when to talk to your doctor. But also, these are usually don't get these unless your doctor tells you to. It's unusual for people to for fun measure their blood oxygen.
Yeah.
We're a little weird.
I bought one 3 years ago for fun.
Yeah, well, you were doing weird body hacking stuff.
That's right.
Okay, so great. So you have this pulse oximeter, and I thought it would be neat to take it apart and see what's in it, because these are fairly simple devices. The thing that's actually really good about this one is it's calibrated, and they even have the calibration data here. They even show the plot of the calibration. I guess this is the bias for the readings, and also because it's every device, it will vary a little bit with temperature, it'll vary a little bit with humidity, but they actually did pretty good calibration for this pulse oximeter, which is neat. And they have all this data in the data sheet. They also have the specification here, so they guarantee 2 BPM accuracy and between 70 and 100% SpO2, they'll plus or minus 3%, which seems about right. So and that's actually pretty normal. These are not meant for measuring below 70. That's when you would get a medical grade, really fancy one. It's actually, I've read a little bit about this. It's actually apparently quite hard to measure. Once it's below 70, it's we're not good at measuring the exact percentage below that, because again, it's quite rare. Okay, so for the pulse oximeter, I thought let's start taking it apart. And then I'll zoom in. So I took the battery cover off, and I actually kind of took this apart already, so some of the screws are missing. But let's just pretend like I'm doing this for the first time. So they take the battery cover off, and then you take off this little piece of plastic. And then this is the power connector. And does kind of what you expect. It's got the little springs here for the 2 AAA batteries. I actually kind of like that they use AAA batteries because they're easy to get, they're easy to replace. And then on the other side, actually, you can see this is, I'm trying to remember, this must be the LED emitter. Hold on, let me see. So the battery, I put my finger in this, I turn it on. Yeah, so the LED emitter is next to the battery pack. So this is an emitter. And what's interesting about this emitter is you can see there's only 2 legs, but this has both infrared and red LED elements inside of it. And you're like, wait a minute, if you have 2 LED elements, I should have 4 legs. Anode, cathode for one, anode, cathode for the other. They did a little trick here. So these are actually back-to-back LEDs, and that's quite usual. Although I don't know why exactly they do this. Is it maybe a cost-cutting thing? It doesn't really matter. This is just a common. I've seen this in pulse oximeter designs. So one of these is the red, anode, and then cathode, and then the opposite is the anode and cathode for the infrared LEDs. So they alternate. Maybe one thing that is kind of nice is there's no way for you to have both LEDs on at once. Maybe that's part of the design. And then you can see this connector, this flex PCB goes into the body, and that brings the battery voltage down and then brings the IR and red LED control up. Okay, and then this.
All right, I'm going to mention we got some fan mail.
Yeah.
I'll leave out names and everything because I don't know if they want this
to
go up, but it's someone talking about the ranges. So 95% plus is normal, best to monitor, and if you see a drop over a period of time, that's when things are bad. This person, their mom has COPD, and they watch it a lot, and 90% or lower, that would generally indicate a problem.
Yeah.
Great video. So yeah, this is neat. See, this affects everyone. This is neat stuff.
That's true. No, many people, have pulse oximeters. If you're doing there's many therapies that can affect your lung or your oxygenation. Yeah. So it's not unusual for people to have these.
Everybody's getting smart about health, so it's good.
And I see also a lot of people. We've had people contact us and say, "I want to learn how to make a pulse oximeter," because, like, for example, 2 weeks ago, you couldn't buy any. Like, there were none available anywhere in the market. And so we had somebody who was desperate to build one because he's like, "I need a pulse oximeter to measure my friend's blood oxygen." I said, I don't have one. I don't know where to, you can get one anymore. And then they, the next day they found some. So that was a good thing. But being able to build these kinds of devices, it's not too difficult. Actually, the electronics behind this is pretty simple. All right, so let's look at the other side. So this is the the main board, and you see this is the other side of the flex PCB. So the battery comes in here, and then there's a couple different electronics. I'm going to turn on the lamp. Maybe I can see. Maybe like that. Okay. So there's actually another side. So I'm going to remove this so I can pop out the PCB completely, and then we'll switch over to the computer so we can actually start identifying these components. So, and then it's actually a double-sided PCB, so you can see actually this side's a little simpler to look at. So let's look at this first. So first you've got your standard 128 by 64 0.95 inch diagonal OLED. We stock these for like a decade almost. They're extremely common. They're extremely inexpensive. They look great. They're easy to use. They're very readable, which is nice. You can kind of read them outside. You can definitely read them inside. They don't have TFT washing outness or angling. The angle you can't see very well. They have 90 90 90 90 visibility, which is great. Got a tactile button. So this is the mode selection. Here you can see a little power inductor. So this area here, because this is really close to the battery cable that's coming in here, I didn't look up this part. I couldn't quite figure out exactly, because there's no marking, but this is a boost converter. So this is going to take the 1.5 volts, 1.3 to 1.5 volts times 2. So probably about 2.5 to 3.5 volts and maybe boost it up to 3.3, or maybe it's a buck boost. I don't know. Basically, this is your regulator circuit here. It also could be a boost for the OLED, but I kind of didn't want to pull this apart to see whether this goes to the OLED power supply or not.
Is that a debug programming port? The 5 unpopulated through holes.
This is the pogo pin test pads for the chip. So this is the main microcontroller. So the power comes in, is regulated. There's a bunch of analog circuitry here, and then this is the first chip that has a part number on it. So it's kind of hard to read, but I looked it up. So let's switch to the computer.
All right.
And it's a CY8C4126AZI-S433. This is a Cortex M0 from Cypress. DigiKey has it for order if you wanted to. It's not too expensive, but maybe in China where this is made, this chip is more available. Why'd they pick this chip? Probably because they knew it, and maybe it was inexpensive enough. Seems like it has pretty good peripherals. It has a reasonably large flash, 64K, TQFP, 48 pins. That's plenty of pins to drive, the OLED display and stuff. And
I wonder if someone's gonna buy 500 chips on DigiKey like the last time we did Disco Ladyada.
They're not on stock, so they can't.
Non-stock, okay.
This is actually quite similar.
Sign up, everybody.
This chip is quite similar to the SAMD21, right? It's just the Cypress probably has better sales reps in Shanghai than this company is. But this is a Cortex M0. So this is a fairly powerful chip, but it's not overkill. I think it's a good. That's what I would pick. Something around this power and capability. You want something that can do floating point because you're going to do all this math. You want to drive this OLED, so you have to have plenty of RAM to buffer the entire display. But you don't want to go too crazy. Okay, so that's the TQFP. So the next chip down, and go back to the overhead. The next chip down is, there's actually 2 chips, and I kind of know what they're for, but it's like an LN 3005, and the other chip is SGM 48752. So let's go back to my computer and I'll show off these chips. So I just typed in the part number, and this is this is one of them. It's a analog multiplexer. So what this is probably being used for is driving. This is part of the infrared LED driving, because you have to alternate the anode and the cathode, kind of like an H-bridge. So I think this is kind of like an H-bridge acting kind of device. It's definitely near, it's on the way to the LED. So either it's the input from the it's input from the LEDs, or output from the LEDs, or input from the photocell. And then the other chip is also an analog switch. It's a little bit weird, why are there 2? But I guess there's 2. One is a quad, and then one is a dual. So yeah, it definitely has something to do with the LED switching back and forth. So that's that. Okay, and then let's go back to the overhead. And then this is the photodetector. And you can definitely tell it's a photodetector because you can see this gigantic crystal here. So this is it's very simple. It's either a photodiode or a phototransistor, probably a photodiode. And then, it's maybe this over here is an op amp, or over here, I don't know exactly where, or maybe it's part of this switching. Maybe this is a multi-gain op amp, and so they're using, they have a single op amp for increasing the signal, and then maybe this is switching a different resistors into the feedback path. I don't know. That is, without a schematic, I'm not going to spend the time. But you can see there's one detector for both red and infrared, and that's not too unusual. Usually they have 2 different LEDs for the 2 different wavelengths, but then only 1 detector. And then over here, it's actually kind of familiar. This is a buzzer, and we have this exact same buzzer on the Circuit Playground Express. So I know this. This is like a 7 millimeter buzzer. And then over here, you can see the flyback diode and the drive transistor. So this is being driven by this chip as well. And then maybe this is a RX-TX debug port. Who knows? Maybe it's I2C debug. There's basically some debugging port. And you can see the PCB is actually kind of nice. They've got like nice ground plane. It's a proper PCB, FR4. So they didn't cheap out. This connector and flex is quite nice quality. The OLED's a nice OLED. Has pretty good refresh rate. So that's the design. And then I wanted to show how you could find the infrared LED if you wanted to find a dual infrared LED on the computer. So I'll close this mystery op-amp. So, because I was thinking, like, how do you find a dual LED? So what I did is I searched for infrared LED. So that's kind of the rare part. And then I went to infrared UV visible emitters on DigiKey. And then for type, you see how it says like infrared and then comma visible? That's good, because that's what I want. I want a dual mode LED just to kind of match the LED that's here that has, like, 2 elements in it. And you can see, like, this LED has 4 pins because, people like that. But, of course, you can connect them crossways if you want to have a back-to-back diode. This one also has 4 pads. This one has a really great look. I like the look of this one. This is kind of cool looking. But you can see the red on the left and then infrared on the right. This one is like a 4 LED, multi-nanometer LED. I don't know what that's for. And then some more hardcore ones. This one's kind of a nice LED too. But, these LEDs, anything you see here that's going to be 940 nanometer plus 660 nanometer, another thing you'll see is they're high current. And that's unusual for like an SMT LED. Usually SMT LEDs are like 10, 20 milliamps. These are going to be about 100 because that's actually the amount of light emitted when they pulse read the pulse oximeter data. That's not unusual. Infrared LEDs, you can drive them kind of hard. And then the red LEDs are also pulsed kind of high to, shoot that LED waveform through the fingertip and read it on the other side. Because like your finger's not very transparent, it's kind of opaque. So if you want to read the signal on the other side, you have to have something quite powerful to really light it up. All right, okay. So that's my teardown. If people have questions about...
No, we hit them as you were
Sweet.
Doing the show. So,
yeah, and this has a lens too.
Yeah, we're trying to get in the habit of doing these, fast so we can do lots of them. So we're getting back in the zone. Not bad. We did one on Sunday and we did one today.
Yeah.
A little bit of a reminder for folks what's going on. So we're operating at essential orders only. Adafruit was deemed essential business. We've been doing some manufacturing, logistics, engineering, R&D, and more. More information about that on our site. We're doing shipping. We got out 2,000 essential orders just in the last few days. The entire shipping team, this lady and I ship these packages.
Yeah.
But getting the face shields to the government next week, getting the face shields to local hospitals, specifically Mount Sinai. That's happening tomorrow again, and then also next week. And then we'll have more sensors and parts that we're making for medical equipment, things like ventilators and more that we're manufacturing. So that's happening all right now too. For folks who ask, because they do, how to support us during this time, well, first, please take care of your local city, local state, and things first. It's the most important thing.
It's a good idea.
But if you're still like, I got to do something for Adafruit, cool.
Maybe they got like a big stimulus check.
You can get a Adafruit gift certificate. That helps because you can buy something. You can get that now and then spend it later when we're shipping, regular orders. You can get Adafruit IO Plus. It's an IoT service that won't hurt your feelings. That has a great privacy policy and fuels a lot of the IoT projects out there. You can also get an AdaBox. We have like 20-something slots left. We'll be shipping pretty soon. So now's a good chance. And, of course, stay tuned to our shows that are coming up and more. We have Ask an Engineer. That's Wednesdays at 8. We have Show and Tell, which is now an hour at 7 p.m. Noah and Pedro, 11 a.m. on Wednesdays. John Park's show, which is on Thursday at 4 p.m. We have different segments in the various shows, from 3D Hangouts to Eye on NPI by DigiKey and Adafruit. And we got a lot going on. Today there was a deep dive that Scott did with the ESP32S2.
Slowly making progress.
So this is the Ada News Network. We've got a lot to offer because you can only watch so much news. So with that
we're definitely
being said,
more fun than the news.
Yeah, I mean you should watch the news a little bit, but not all the time.
Not too much.
Someone in chat says this: a reminder that DigiKey can deliver all the stuff that you would normally get from Adafruit. That's right. So that's a good reminder. So if you're wondering, like, I want to get like a Circuit Playground Express, but I know that's not considered an essential thing, just go to DigiKey.
Yeah.
Thanks, chat, for reminding me of that. And then Adam says, definitely missed the Ladyada teardowns. Yeah, they're back.
They're back, and they're medical.
Yep. And then when someone says, when they rule the world, we'll be in charge of all this. I think we do a pretty good job, but the person who could do a good job, they rarely get that job. So we'll see. I would like to help people, and I would take a crack at running things for a bit. Couldn't do no worse.
You can run Adafruit pretty good.
Doing okay. Doing all right. Then the next thing, let's see. Someone's a full remix of Eye on NPI theme. Yeah, isn't it cool? That's a good song. So
remix it. Go for it.
We might do an extended track on that.
Deep cuts.
Eye on NPI. NPI. Yeah, it's good.
Yeah, it's good. Thanks,
all right,
Tom.
that was Tom, who's in the UK, who's an Adafruit team member. So we're all in this together. So no looking back, only new ways forward, everybody.
That's right.
Remember that. That's what we're doing.
Okay.
And with that is that's Ladyada. Bye, everybody.
Thanks, everybody.